Okay, it's 1 o'clock. That always means one thing. It's another episode of our HDF Clinic. Welcome, everybody. I checked before our meeting the Google document. I didn't see any questions there, any new questions, but that's okay. We will just sort of go through our usual motions. Except for, I'm going to pause. Are there any questions right here and right now? No? Okay. Then we'll just jump right in. Last week's highlights, first announcements, not really new announcements, but still good announcements, interesting announcements. Number one, this is coming up this Friday. This seminar on using HDF5 and HSDS for open science research at scale. I think it's going to be very interesting, and I'll definitely be there. The second one is, registration is open for the European HDF users group event Hug at EDA, and which is going to take place between May 31st and June 3rd, I believe. On the June 3rd, there's going to be a site visit of the EDA site if you register early and sort of are among the first 50, I think, registrants, because there is a cap on how many people can be there for that tour. So I encourage you to register as quickly as you can if you are interested in seeing the EDA site, which is pretty far along these days compared to 5-6 years ago. Anyway, okay. Before I jump to the forum, are there any other questions at this point?
No questions, Gerd. Go ahead.
Okay, thanks. Welcome. Okay, there were a few interesting things on the forum. Number one, this is sort of our mystery error. It continues. Remember that was where a user reported seeing read errors on Windows. And in the meantime, we were able to get a sample file from the user. And I looked at the file and I had no trouble reading it, looking at it, nothing unusual there. So fine. We also, we asked the user to actually, instead of using the sec2 BFD and sort of generating all these IO requests to use the core BFD and run the IO workload in memory, so to speak, with just memcopy, and that seemed to work just fine. So that's a good data point. Unfortunately, it doesn't really tell us where the real issue is, but that seemed to work just fine. And I think we've really reached a point where, in order to make any headway as far as the root cause of all this goes, we need some way to reproduce that behavior. Okay, the user said it occurred randomly and so forth, but let's say we can write a little C program or something like that, run it on a Windows machine and run it 100 times, and maybe 10 out of 100 times we see the error. That would be good enough, I think, to do a refined analysis. But without that, it's really, really difficult for us to say one way or another if the problem is in our code or if the problem is maybe in the user's code somewhere. That's really hard. So for the moment, I'd say the mystery continues. And if you follow that thread, I've asked the user if they can, at least in general terms, sort of describe their, well, first of all, the life cycle, in the sense if the file just gets opened once and then they do multiple reads on it, or if they in between open and close it, and then what do they do? Do they iterate over the file structures? Are they looking at attributes and so forth? So that we might be able to put together a simple program that they can then run, and if they can reproduce the error on their systems, then it would be a miracle if we couldn't reproduce it on our systems, I think, although never say never. And but yeah, I think that's where we are with that. Any other questions on this? No, I mean, there's really
No.
Yeah. Okay, then there was an interesting question about symbolic links with relative path, and that and there was a secondary question to this. I think part of the confusion here comes from, well, first of all, the meaning of what does relative mean, and sure, metaphorically, you can think of HDF5 as a file system in a file, and then by extension, when you look at certain shortcuts available to us in a shell, like in a bash shell or a C shell, unfortunately, some of those metaphors don't really carry over to HDF5. First of all, in a shell, you have this concept of in a file system, you have that concept of a working directory, and that's fine. You can think of that in HDF5 as, okay, I have a handle, a runtime thing that refers to a certain HDF object, be it a file, an open file handle, or a group handle, or a dataset handle, and so forth. But then, so the meaning in HDF5 of relative always means relative to that handle. So if I have a file handle, for example, in your head, you can almost say, well, that is synonymous. Should a group handle be required? Well, the fallback then is the root group. So the file handle has sometimes, it takes on different roles, and it can take on the role, for example, as being a file handle, but also being considered the root group handle. So if you specify a path relative to that, then yeah, that path will be interpreted with respect to the root group. Now, so that's the first thing, relative. And then talking about in a shell, certainly you can move to the parent directory of a given directory of your working directory with this ... alias or shorthand or abbreviation, whatever you want to call it. And but that unfortunately cannot possibly work in HDF5. I mean, it can work under very restrictive circumstances, but fundamentally, in general, it cannot work. And the simple reason is that in, as we know, these profiles or group structures, call them that, that we have in HDF5, in the most general case, they are not just graphs, they are certainly not trees, they are what we call multigraphs. And multigraphs really means that, for example, between two given nodes in that multigraph, you can have multiple edges. This is something that doesn't happen in an ordinary graph. Maybe in a directed graph, you could have an edge going from one node, from node A, let's say, to node B, and then another edge. So you would have a cycle from node B to node A. But in HDF5, things can get be even crazier, in the sense that if you have these two nodes A and B, you can have multiple links going from A to B or the other direction. There's no limitation on that. And so with that in mind, if you are at a certain node in this multigraph, generally speaking, the concept of an ancestor or a parent, that there would be a unique ancestor, that in general doesn't apply. And that's why this ... notation, unless something really has a tree structure where each node is either the root node or has a unique parent, that is not possible. Now you could say, well, couldn't a tool or a function check that at runtime? In principle, yes, but this is a very expensive proposition because unfortunately, we are talking about handles here. So if you are at a certain node, a group, a data set and whatnot, then in general, you just have a very local view of things. And from sort of exploring your neighborhood or looking at local information, there is very little that you can infer or conclude about the global structure of this profile. So by just looking at one node and the links around that, you cannot decide one way or the other if this is a globally as a graph, a tree or something like that. So this is just not practical to in a way implement efficiently this sort of traversing, or in a way backward traversing to the parent, to the predecessor, the ancestor, whatever you want to call it, of a given node. So that's where that breaks down. Now, there was a second part to this question that the user asked, which was what characters are sort of permissible in linked names, and or sort of the other way around, what characters are not permissible in the sense that they have special meaning and as such cannot be used in a linked name. Well, I listed them here. Fundamentally, it's two characters or the combinations of two characters. One is certainly the slash, which acts as the sort of path name separator when you specify an HDF5 path name to separate those links. You cannot use the separator, obviously, in a symbolic link name, or in a link name, it's symbolic anyway. Also, the dot character has a special meaning in the sense that it's interpreted similar to what it is interpreted in a file system or in a shell, which is sort of, the current working directory, so to speak. And likewise, the combination dot slash or the combination slash dot slash. And I probably could have added also dot slash or dot slash dot slash dot. So again, those are those have special meaning and all refer to the current object, and so in a way are you can contract them. However, without the involvement of the slash, and the moment you have more than one dot, that turns into legitimate link names. And I provided a simple example in that post where I basically, in the root, I created a new group that I linked as ... to the root group. And then inside that, then I created another group and linked that with the link name ... to the group that's linked as ... in the root group. And that creates an HDF5 file, a very uninteresting one at that, but that has 3 groups, the root group and then 2 other groups. And the first is linked as ... with the link name ... in the root group. And then that second group is linked in that previous group with the link name ... And so these dots, 2 or more dots, are perfectly legitimate link names. Whether that's a very good idea to do that is another question, but it's certainly legitimate. And of course, likewise, spaces. Spaces, single spaces, multiple spaces are legitimate link names. So you could create an interesting HDF5 file where everything is, where all link names are just multiple spaces. So I think if you opened that in HDF view, it would look very bewildering, but it's perfectly legitimate. And likewise, again, by default, the encoding, the character set that's available to you is ASCII, but with a simple link creation property list, you can set that to UTF-8 encoding, which means that except for these combinations here with the slash and the dot, any Unicode code point, any other Unicode code point can occur in an HDF5 linked name. Okay. Okay. Any questions about that?
Gerd, yes,
Yeah.
I had a question. Do you think that the perception of the original poster regarding /DSET with the Unix convention on do you think that's widely held among HDF5 users? It seems like it might be.
Yeah, and unfortunately, it is a misconception, because the HDF5 library will look at that link name and think, okay, it will look at the current handle, which might be a group handle, the group in which that symbolic link with that destination exists, and then it will say, okay, it will try, do I have a link name ... and then it will fail there already, but unless there is a link with the name ... and then it will append that next link name and try to resolve or traverse it, and yeah, it will typically fail. Yeah, it is unfortunately a misconception, and it might be even, I'm not aware of it, but there might be actually, I'd be surprised, but I wouldn't, well, I probably shouldn't be surprised. Maybe one or two of the tools that we have may support that syntax. Again, I don't know if I should or shouldn't be surprised if that were the case, because yeah, from a conceptual sort of graph theoretic point of view, these HDF5 profiles, they are not graphs, they are not trees. So the idea of the parent of a given object is, other than in very special cases, generally not defined. It's meaningless. And likewise, I think the user was also asking about levels. Again, this is something, if you have a tree, then you can sort of take the edge distance, so to speak, from the root of that tree, and that might be a way to define levels. But in these very general multi-graph structures, the concept of a level just doesn't make sense. And so yeah, so I can take it maybe as a homework, or speak with a few of my colleagues to find out if, for good reason or by accident, we implemented that ... thing somehow. Again, I'd be surprised, because again, it can be a link name. It's a legitimate link name. So if the user specified it like that, it would create an ambiguity, because would they mean the ancestor, the parent, or would they mean the ... link relative to the current handle? That, again, a tool could figure that out, but it just adds to complexity and processing. And if both existed, then the question is, well, which one do you mean? And yeah, not
Yes.
really an answer, but
yes. Well, I would, my suspicion is that that a lot of users of HDF5 don't exploit the full multi-graph nature of the technology, and therefore they do tend to think of things in sort of a acyclical directed graph view,
Yeah.
but that's not really correct.
Yeah,
is what you're saying.
Right. And I mean, while I would say this is a little bit, I wouldn't call it esoteric, sort of maybe more than most people need, it is still, I think, a feature that quite a few users like, because it gives them the ability to define multiple profiles or multiple hierarchies, if you want to call it that, on top of the same data. And that is an ability that you do not have if you are just dealing with a directed acyclic graph or something like that. Whereas if you have that flexibility with the whole multi-graph business and so forth, then that's not a problem.
Yes, because then it's a matter of traversal, correct? Yes.
Yeah.
Yes. Yeah, I find that interesting, because in the scanner, the H5S scanner, it uses the Boost graph library, and it does use, and that's very configurable, and it does require the multi-graph templating in the Boost graph library.
Ah, okay, good point. Yeah, I should check that out. I did not know that the Boost library had that.
Yes, yeah. It's a little bit, I guess some folks might say long in the tooth, but it's quite good.
Yeah, because a lot of algorithms just don't work, or you have to work much harder to figure certain things out. And
yes.
yeah.
But BGL is I've found it to be excellent. It's pretty amazing.
Okay. Next, so that was an interesting one. Also, the user was wondering, I think the way he described it, he had he created a file, let's say in H5Pi, I think was the example, and then he opened it to inspect it in HDF view, and he probably saw what he liked, and but then he thought, well, let me in HDF view, for convenience or otherwise, add a data set or create a group or add an attribute, something along those lines. And then the question was, well, wait a minute, when I then look at the same file without having closed it on the Python side, I just cannot see this newly created object. I cannot see that attribute, that new group, and so forth. And the question was, well, how is that the changes somehow don't seem to propagate? And of course, it reminded me, and this time I didn't add a copy, but one in one of the very earlier episodes, we talked about what makes the state of an open HDF5 file. And we had that little cartoon where we basically showed that the state, if you want to call it that, of an HDF5 file is really a hybrid that has two portions. One, certain state information that resides in memory and typically gets flushed to the file either by calling flush explicitly or when the file is closed. And then there is certainly the in storage, in file state that is sort of the other portion of that. And so if you, like in this case with H5Pi and HDF view, if you were to open the HDF5 file using these two different processes in the sense of operating system processes, because the Python shell and the HDF view, the JVM, you would be actually launching a JVM instance there. They run in different process contexts, so to speak. They run two separate copies of the HDF5 library, so to speak. And let's assume that, one of them or more of them are actually opening the file with write access without inter-process communication. So the Python application and the HDF view in this case, they do not inform each other about when they create an object or unlink a data set or something like that. So if you do that, you are creating automatically a what one might call a coherence problem, in the sense that then you will have a state view in the context of H5Pi of that HDF5 file, and you will have another view, another state of that HDF5 file in the context, I forgot what I said first, H5Pi and HDF view. So you have two views, and the moment one of them, without inter-process communication, creates a new object, the other process will not see that by default unless you flush it for the process that has done that change or that creation, and the other process actually rereads the file, because otherwise, there is just no mechanism that would sort of prompt or trigger that other process to pick up the changes, the updates. And then, so if they wildly, in an uncoordinated fashion, were to commit changes, write changes to this file, then yeah, you're setting yourself up for a consistency problem in the sense that there might be corruption and so forth. So don't go there. And if that is a use case for you, and there are many legitimate use cases, then there are sort of features that you can use to avoid that situation. One is sort of the swimmer. We talked about that several times, single writer, multiple reader, or you have to then by hand implement some kind of inter-process communication, or you use something, we talked about that again briefly last time. You would have a dedicated, call it a service or a dedicated process that would process I/O requests, be it reads or writes and so forth, but all the other processes would not really directly interact with the file, but would use this sort of this proxy, so to speak. Okay. Yeah. Any questions about that? I mean, yeah, nothing earth-shattering here.
No questions.
Okay. And then there was another post that was good. Yeah, somebody wanted, and admittedly new to HDF5, wanted to talk about reading just a portion of a data set, presumably a very large data set. And yes, it's one of these occasions where one might say, yeah, that's what HDF5 is all about, or a big portion of it is about. And it was wonderful to see how many people really responded. And Stephen even provided a very comprehensive example in H5CPP and a nice graphic with that. And that was great to see. Okay, that's what stood out for me. And unless there are any other questions, we're running a little short on time, but maybe we can sort of begin this here today and then finish it next time, unless there are any other questions.
No questions.
Okay, good. So what I wanted to get into a little bit is a discussion about HDF5 applications and clients in cloud-based environments. And so there is this cartoon here, and we'll probably not be able to sort of cover it in full here. But so the first thing you might ask, well, what's the difference between an application and a client? Well, looking at my two users here, sort of what the mental picture that I would hope both of them have is that they are using something that looks like HDF5 in the sense of the HDF5 data model, meaning you have a sort of something that you can think of as a logical file, as a container that has a root group, and then from that root group you can discover all the good things that are stored in that container. And so I would like to use the term application whenever either you're dealing with the HDF5 API that we are all familiar with, and or you are talking directly, that's what I call a facade here, you are talking directly to a natively, in the sense of the file format specification, formatted blob. So you can bypass the HDF5 library if you're familiar with the file format specification. You can go directly there and sort of pick out the bytes and byte ranges that you want, and users have done that and had good success with it. Or so you are either doing that, or for a client, that client would typically speak in a protocol such as HTTP or HTTPS, and but not really be necessarily constrained by the API, the relatively large API provided by the HDF5 library. And then on the storage side, before we go into details, and we won't be able to, unfortunately, on the storage side, in a cloud-based environment, you would have things, you can have a parallel file system just as you would in in a large data center or compute center in your university, or even in the cloud. So there would be a file system like OrangeFS or Lustre or something along those lines. Or you would have sort of an object store, a cloud-based object store, or if you have it on-prem, something like OpenStack, for example, you would have something that has a, let's say, S3 compatible interface. And then the HDF5 file might be stored in there either as a blob or in some kind of dispersed or shredded form where HDF has somehow be decomposed into objects in this object store. And then you would have some metadata that would tell you how to piece these objects together to sort of reconstruct this logical view of an HDF thing, so to speak. And yeah, unfortunately, we are out of time, but I'm just setting the stage here. So next time, let's come back to that and then see the different paths that we have. And then there are also some interesting loops where we have to ask ourselves, well, if I start here and then upload a blob, and then that blob gets sort of converted into objects, and I look at this from here, are the two things that I'm looking at really the same? What's the same? Under what circumstances are they the same, and so forth? And we'll come back to that next time. So thanks for coming. And unfortunately, we are out of time, but come back next time and we'll continue.
Okay. Thank you, Gerd.
Bye.